Chemistry, we're on to part 2 of the day 75 week basis assignment. We're going to continue practicing some rice tables here. I'm doing most of these for you, pretty much all of them. It's important that you know how to do them though. So you should always try to do these before I do them. Otherwise you're just not going to learn them. So go ahead and see how much of this you can do, and then you can follow along with me and check it and see how you did. Okay, so a concentration of 2.6 molar methylamine is placed in aqueous solution. There's the Kb of methylamine. Use the generic base equation. Okay, so you don't know what the formula for methylamine is. That's why you use the generic equation. So we don't know even whether it's an ion, that is a conjugate base of an acid, or whether it's just a electrically neutral base. Let's just assume it's an electrically neutral base. So we're simply going to represent it as B plus H2O. And the H2O is going to donate a proton over there. So that's going to produce a B with an extra proton, so BH plus. And then the water molecule lost a proton. And when a water molecule loses a proton, it becomes a hydroxide ion, OH minus. Okay, so that's how you write the generic form. It doesn't matter. You never have to know what the formula for methylamine is. Okay, so let's go ahead and do this. And I'm going to do this silently. See if you can fill this out. We've done this quite a few times before. Okay, so again, you start with concentration of 2.6 because that was given to you. You weren't given any initial concentrations of the conjugate acid or of the hydroxide, so you start with 0 there. You always say that it's going to go down by X on the reactant side and the coefficient is 1. Over here on the product side, it's going to increase, plus X, coefficients are also 1. So this becomes 2.6 minus X is there, 0 plus X is there, 0 plus X is there. Now we're going to go ahead and write the law of mass action using a Kb. Now we're going to substitute the values. Okay, we're going to use the simplifying assumption to eliminate that X. We're going to put those together to make them X squared, so we come down here. Okay, we're going to come over here, multiply both sides by 2.6. Okay, now we have X squared equals this. Come down here, and I'm going to go ahead and just bring this over here and take the square root of both sides because we're trying to find X. And I'm going to multiply these two together and put it down here. Okay, and we get this. All right, take the square root of that. And we get X equals this. Okay, so that's our value of X. What's the hydroxide ion concentration? So here's hydroxide, and the concentration at equilibrium is X, and that's this value right here. Okay, now what's the pOH? pOH is negative log, and that gives us 1.4 pH. Okay, so there's the pH right there. And finally, the hydronium ion concentration. Let's do it the easy way. And what we get is a very small number, 2.5 times 10 to the negative 13. And that's molar. This is also molar up here. And those are all of the answers. We'll do the 5% rule. So X is 0.039. Didn't ask for it, let's just do it. And the initial concentration of the methylamine was 2.6. Okay, and we get 1.5%. So we were under 5%. So that means the simplifying assumption of eliminating that X right there is valid. Okay, next page we go on and we do a common ion. Okay, let's read this. A concentration of 2.6 molar methylamine is placed in aqueous solution. A conjugate acid of methylamine, a conjugate acid salt of methylamine is CH3NH3Br, where Br minus dissociates in solution. And it says there's a concentration of this conjugate acid salt of 1.2 molar. and then there's the Kb. So let's work through the acid salt first of all. So methylamine is, okay, so there's the base. That's the base methylamine. So you add a proton to its acid. Its acid's going to have one more proton. Its conjugate acid is different by one proton. So it's going to look like this. One proton more. So this is the acid, and this is methylamine, and that's a base. Okay. Now what you want to do is find a salt of the acid. Okay, so this, by the way, should have a plus sign. You added a proton to this, so this acid is a plus. Now you want to turn it into a salt that you're going to put into the solution, and you want that salt to have a positive charge, a negative charge attached to the end here. That will always dissociate. So we're going to pick bromine. Bromine has a negative charge. So this is the conjugate, using some abbreviations, acid, salt. Salt is a neutralized acid or base. So it's going to become CH3, NH3, and then we're going to attach a negative sign to that plus sign, Br. And if your solubility rules say bromine will dissolve with anything, dissociate with anything, except mercury, lead, and silver. So this is not one of those three, so it will dissociate. So when this gets into water, the Br will come off, become a spectator right there, and then what you'll have is your conjugate acid of methylamine. All right? So we're going to go ahead and write this out. I'm going to use the actual formulas so that you can, because they're a little bit more involved this time. Okay, so here we go. So it's, the water's going to donate, once the bromine's broken off, it's gone. It's going to donate a proton over here. So now it's CH3, NH3 plus, and that's going to also produce a hydroxide out of the water. You took a proton away from the water, okay? So it's a little bit more involved formula. Sometimes this is where using just generic base and generic acid notation might seem easier to just go ahead and do it that way. Okay, initial, we have 2.6 here. We never use water. We're starting with, now we are starting with a concentration of the conjugate acid. It's 1.2. This is a common ion effect. And we're not starting with any hydroxides. Okay, let's go ahead and fill this out. Okay, so make sure you understand how everything there was arrived at. Law of mass action. Okay, simplifying assumption gets rid of this x and this x right here. So you have 1.2 times x on the top. And we're going to multiply both sides by 2.6. and divide both sides by 1.2. That isolates the x. That's what we want. Okay, so again, what we did there from this step is we multiplied both sides by 2.6 and divided both sides by 1.2. Cancel. And whoops, I forgot to write the 2.6. That's the one that was already there. Okay, so cancel and cancel. Okay, so now all we have is x by itself there. So it's x equals all of this, so we're going to multiply all of that together. Okay, and we get this for x. Okay, so there's our value of x. What is the OH concentration? So OH is right here, and the OH concentration is x. POH, negative log. It's going to be, let me get down here on the screen. Okay, negative log, and we get 2.9 for the POH. What is the pH? So I think you know the formula by now. We're just going to take 14 minus the POH. That's going to give us 11.1. H3O concentration. I should go ahead and write this. pH equals this. Okay, and then H3O concentration. And that equals 10 to the minus pH. Okay, and that's going to equal minus 12. Again, this is a base reaction, So you're going to have very little hydronium in this, and that's molar right there. Alright, and it says compare the values in problems 7 and 8. That should say 6 and 7, the last two problems that we just did. So again, what's going on here? Alright. Okay, so in problem 6, we ended up with a pH of 12.6. That's way up in the base range. So why? Because without any common ion over here, the reaction was free to move from reactants over to products. So it was free to create more OH minus, create more bases there. Alright? When we had the common ion here, right here, it made the room on the right side more crowded. So the reaction was less free to move from left to right. So it wasn't going to move as much from left to right. Therefore, it wasn't going to create as many hydroxide ions. And so you ended up with a pH of 11.1. So again, it's 11.1. And over here on this one is 12.6. So this is more basic without the common ion. This is less basic with the common ion because the reaction cannot proceed forward. All right, that takes care of this lesson, and I would get started on this as soon as possible. Get lessons in on time for the last 3 weeks.